Good morning, everyone. Today is Saturday the 28th. This is a very different kind of video. It is a long video. Pardon me, sometimes I may look up, I'm looking for something for the video and the computer is just not cooperating because the way they program these days, apps, when you leave a window open, it continuously builds memory, so of course the memory gets eaten up. As a former computer engineer, I find it incredibly frustrating. The entire app movement, it was all centered around these things, which of course are incredibly flawed security-wise and everything else. But the desire to move PCs into using apps but not respecting the difference in how they function versus the phones is really incredibly frustrating. So speaking of which, this video is called the Enlightenment. And this is actually an extension of something that has already been, whatever you want to say, prophesied for a long time. We've been living in the age of the unlaw ever since World War II, when the swastika was flipped backwards. And the swastika has always been a sign of enlightenment in life, and of course, very famously was reversed by Hitler, and then massive genocides were done. And now, what do you see? You see you got Holocaust deniers, you got flat earthers, you got really everybody under the sun trying to bring us backwards in our progress. And this is a really, really big issue, guys. So I want for a moment, if you could, even if you don't believe a lot of the things that I'm into, just take your walls off for a second. In fact, let's talk about the very first topic here is scientific conservatism versus skepticism. Okay, skepticism is a healthy thing in science. It is the application of critical thinking to any kind of idea. Any paper that is put out, it needs to be tested. Its results need to be tested. Of course, it needs to be well cited in the first place, and it needs to be verifiable. If a concept or hypothesis is not verifiable in a laboratory or experimental situation, it is not a scientific hypothesis, no matter how much you love it. Again, there are a lot of things that I really like to believe in, like extra-dimensional space. In fact, I have an entire diagram of 6 different kinds of multiverse. I used to really be into string theory. But these are things that you can't prove, right? You can prove the quantum realm because you can prove the Planck length. And that Planck length is confirmed in laboratory experimentation and anytime you use a laser, which is all the time you're using lasers. We have proven the quantum realm. Are things actually quarks, or is quarks just a good model? Doesn't matter. Quarks and all the particles are measured in electron volts. They are measured with charge, which, remember that if you have read my paper PIMS, and if you've read the magnetic universe, you will know that the PIMS is the EMF, is the unified ether field. Everything that we've been looking for in terms of a unified field theory is already contained in the concept of plasma electromagnetism. We just haven't figured out all the aspects. And according to Taoism, we never will, actually. And I'm going to get to, here in a second, one of the aspects of which almost nobody is talking about, and there's a good reason for it. Now, scientific conservatism is more akin to, for example, when astronomers fought Edwin Hubble to say that the universe was no bigger than the solar system, or at least not much bigger. And of course, Hubble famously argued against this because it was nonsense, based around human egocentricity, and of course he won. But not all the time do the right scientists win. I mean, Aristotle had the advantage of living after Herodotus, and he lambasted him and kept us in the dark about atoms for almost 2,000 years. Ptolemy's flat earth system was good enough to make decent predictions for a long time. Of course, it wasn't good enough to predict every eclipse and every event of the solar system, so long term it had to fall. But when you have a whole gang of people who say things are impossible, they say you can't drive a car faster than 35 miles an hour or a human's organs will explode. These are the kinds of people like Michael Shermer, who keep us from making any real human progress. To me, I think it is a scientific sin. It is an unforgivable sin if you were to take science into its religious ethos, which many do in scientism. And yet, what we find instead is that there's an entire inquisition of scientists whose sole job it is, that what they are paid to do is enforce the so-called, double the journal, everything has to be double placebo, double blind, evidence-based medicine, all these kinds of ideas that actually, if you study them, they don't have a good basis. Take the double-blind placebo test idea for evidence-based medicine. I'm not against evidence-based medicine, but the best evidence always comes from people. It comes from observation of people. Whereas there are a number of things that you cannot double-blind placebo do. You cannot do any intervention therapy double-blind. Anybody who says you can is nonsense, because you need the physician or surgeon to be aware of what they're doing. Wisdom is a huge part of a surgeon's ability to get the job done, or an acupuncturist's job. It is undoubtedly true that you are better as an acupuncturist after 20, 30 years of practice than you are after 5 or 10 years, let alone 1 year of practice, right? How many beginner mistakes are made even with proper 4 or 5 year education? Conservatism has its place in keeping humanity safe, but it also has its place in keeping us in the past and in the dark. That's why a healthy balance of a openness, a willingness to accept ideas is so important to scientific progress. Without that, we honestly are not going to we're not going to make it as a species another 1,000 years. Or if we do, it'll be a lot like in the Time Machine, in H.G. Wells' Time Machine, where mankind ends up into, there's the idiots on the surface and there's the predators who are surviving below ground, the ones who survived the Holocaust of the end of the world. Of course, in that book, it was the destruction of the moon, which is not theoretically impossible, by the way. Now, scientific progress, by contrast, is always made, well, there's the joke that it's made one death at a time, and that is true. Unfortunately, both the good and the bad sciences are held back by the unfortunate aspect of the journal cliques, that it's political and cliquish, and there's a lot of personal attacks. You look at what happened to Velikovsky. You look at what happened to Houghton Arp. Houghton Arp was an amazing scientist, and he was honestly the Galileo of the 20th century. And you probably haven't even heard of him. Why? Why wouldn't you have heard of a guy who has a couple hundred galaxies named after him? Well, because they don't want you to hear of him. Because if you were to hear of him, then there would be an embarrassment surrounding spectroscopy, surrounding redshift. Speaking of which, I'm going to react right now to this news about the black hole and the confirmation of relativity. Absolutely, relativity is confirmed, just not in the way that they think. Okay, so first of all, there's no such thing as gravity redshift. This is nonsense. Now, there is electrogravity redshift, but electrogravity is not a phenomenon that we yet understand. It's not something that's been put out there, and I'm going to get to that in a second. But as far as how did this redshift happen, if you watch the video released, the redshift occurs and then unoccurs. Why? Because there is a star which is putting out light, and it's electric in nature, passing through an extremely dense electromagnetic field at a Z pinch, at a binding Bennett pinch. There's nothing in that Bennett pinch. They will tell you that you can't see a black hole. It has a radius of 0 and an infinite mass. Now, this mass happens to be a measure of inertia and not of an actual substance. Okay? So it's not, an infinite amount of weight suddenly, collapse into a literal zero space. If you read these scientists, they will tell you it's not a physical radius, right? It's a mathematical radius. And then it's just, magically gone? But no. This is a stellar Z pinch, a galactic Z pinch. And this galactic Z-pinch is basically permanent electromagnetic dynamo at the center of the galaxy. It's what functions to keep the galaxy in its position, in its rotation, and interacting with other galaxies in the supragalactic electric circuit. So this star is passing through. Now it's releasing light. Light is EMF. Right? Nobody's going to argue that. Light is an electromagnetic phenomenon. So it's releasing light. Now that light has to go through massive electromagnetic fields. Of course it's going to be refracted. Of course it's going to be bent. Of course there is going to be some dilation. Let's take a look at relativity. What do you have? In the equation for relativity, you have c squared. Right? Why is that in there? Because light, which is the speed of light here, we're talking about the constant, that's also electromagnetic. How are you going to observe it? You're going to observe it by light coming to you. Even when you have sound coming to you. Let's say you're observing something in the lab or here on Earth. It is happening through the transfer of energy, you asked, through the bumping and therefore the kinetic motion of atoms. That's what's propagating the wave. Atoms are made of particles. Particles are made of quarks. Quarks are measured in electron volts. And if you go and look, quarks are not designated as a physical particle. They are designated as a mathematical electric phenomena. You can go look that up. That's not something you need to rely on me in order to believe. So everything that you're receiving right now is all coming through to you through electromagnetism. This is not a disputable fact. It's just one of those things that no one really wants to talk about. Now, in the beginnings of relativity, if you read my magnetic universe paper, the reality is that Henri Poincaré was solving Lorentzian transformations. Those are calculus transformations created by Lorentz. He was actually in contact with Lorentz himself of Maxwell's equations. Despite the fact that Maxwell's equations are not correct, completely correct, and if you want to see better versions, see Robert de Stencey's New Electromagnetism and New Gravity. Despite that, they are transformations of electromagnetism, not of Newton's gravity. The entire general relativity came from these Lorentzian transformations. Both Henri Poincaré and Einstein were doing it at the same time. The difference is Poincaré died unexpectedly, and 3 years later, Einstein receives, or so many years later, I can't remember if it's 3 years exactly, it's in my paper, receives the Nobel Prize for the work that honestly Poincaré should have received it for. The entire, M equals E over C squared was around since the 1880s. And so was, by the way, quantum. The beginnings of the discussion of discrete energy packets was around since the 1880s. It didn't get a good formulation until 1905. All this stuff was happening between 1900 and 1910. This was an incredibly important time for mankind. The Age of Enlightenment was blooming, and its result was the nuclear age. Now, the fact that they didn't understand the weak and strong force at first is irrelevant, because now we know there's the electroweak force, and of course the strong force is going to turn out to be the same thing. Because why? Because neutrons are actually proton and electrons in an incredibly dense packed orbit. Just as there's orbitals for the electrons at 1s, 2s, 1p, 2p, etc., there are orbits inside of these nuclei in which there's a different behavior. However, the strong and the electromagnetic force are really close in magnitude. So it's only a matter of distances. It has to do with the inverse square law, most probably. And so you have a proton and electron seething around each other. It must be incredible speeds. That is, if an electron is real and not just a fictional particle. But I'm assuming it's real. I believe it's real, personally. So you have these incredibly packed things. That's creating a strong force, and then the weak force, of course, helping to also bind the nucleus, has been shown to be electroweak force, so it's actually already been unified. And all of these things are happening within the atom. And this, we decided to use as a weapon. There's nothing else to say. It's just that in the 1930s, after this fruition, this is all synchronistic timing. In the 1930s, quantum is released to the whole world, is looking at quantum now. Quantum relativity combination into quantum electrodynamics is not far off, but we have to go through this first phase. What happens in the first stages? Most of the things that we understand are incorrect, and usually we're barbaric. Right? In the generation of electricity, as Tesla has said, burning fuel is a barbaric way to get energy. It just is, and he was right. And that was also, by the way, written between 1900 and 1910. So even back then, he was talking about these problems. In fact, the last page or so of his autobiography, he pretty much predicts the entire 20th century and all the problems that we're in currently. So, I highly recommend people read Tesla's autobiography. It's very short. It's not a big deal to read it. You crank it out in an afternoon. So, let's talk about archaeology within science history. This is something that's incredibly important, and it's the next stage for me, aside from keeping up with the suspicious observers and the Thunderbolts and Distinti and various people. It's actually diving in, because the more I dive into science's history, the more I'm finding all sorts of gems. Let's talk about the one that I'm currently working through right now. It's at the end of the Magnetic Universe paper. It's electrokinetics and electrogravitics. Now, strictly speaking, most of the work of T.T. Brown ended up being really electrokinetics. So what is this electrokinetics phenomena? It is the application of extremely high voltage DC, at least in his experiments, to an apparatus in which he brought to his professor Byfield, and they together confirmed and wrote a paper detailing the Byfield-Brown effect. So I want you to go look that up. You can pause the video if you like. Byfield-Brown effect. And when you put a positive and negative charge, and it's a high enough charge, it causes motion towards the positive direction. So essentially, this is confirming what electrogravitics, what mass inertia really truly is. It is solely a matter of positive charge on one end. Why? Because there must be an electrical outer shell on the Earth, and or overall the charges that are in the upper surface of the Earth must be negative, and the ones in the interior must be where the positive are. And that makes sense also from, remember that in physics, the electron represents, and the negative represents actually the yang energy, which is the moving and active and small, and the positive proton is the heavy one, the yin. And that's all because of Benjamin Franklin got it all backwards, which is, he was just arbitrarily assigning. He had no idea that he could do it backwards. But once again, this is the principle. The first thing we learn, we're most likely going to do it backwards. We're going to learn it backwards. We're going to understand it backwards. We're going to make a weapon out of it before we make something useful out of it. And that's exactly what happened with the nuclear age, is that we first started with a bomb. And you know what? In some ways, it's been good, right? It's staved off World War III. Nobody wants to have World War III now because it's no longer fun. In the old days, a good old-fashioned war to bring up the economy was all about muskets and horses and tanks, and now it's not really like that. Of course, they do it in places where the people don't have nuclear weapons. I'm not advocating anybody get nuclear weapons. What I'm saying is that it has probably caused people to be a little bit more respectful of each other. So this is a tremendous power, the power of the gods. So now back to T.T. Brown. So he does this experiment. Unfortunately for him, his work is coming to fruition in that period, in that 1930 to 1950. But just after that, the conservatism of science sets in. If you're not working on quantum or relativity, which are already, now the students of the students, right? The students of Bohr and Schrodinger, etc., are now in control. And the age of the day is look for particles, look for particles, look for particles. And he brings up this concept and how to actually explain the UFO disk phenomenon, and he wants the government to have it. They say, great, thank you, and then he goes and he proposes it to companies and everybody, And they all show a modicum of interest until, boom, he decides to talk about UFOs, which are confirmed now. Like, the governments of the world are all coming out and saying, yeah, we got a problem. There's these UFOs. They threaten commercial airliners, but we don't know what they are. Which they could just be plasmoids emerging out of the Earth, and of course avoiding the plane, but coming close, but avoiding because of electrical repulsion. I don't know. I don't honestly know. Maybe you feel you can feel free to comment. If you think that it's Anunnaki or whatever, you can feel free to say. But I don't know. What I'm saying is that he wrote about the phenomena, and that gave him the black ball. They didn't want to talk about it anymore. Now, guess what? The government did not abandon the Byfield-Brown effect. They put it, and if you want to know where they put it into the bomber, the newer bomber, not the original stealth bomber, but in the newer bomber. And what does it do? It has a positive charge on the front and negative ions being repelled out the exhaust to create the field that you need, and that enables the plane to go a lot faster, but in a quiet manner. To me, this is a huge revelation. I don't know if it matters to you or not. Could the government be participating in really trolling its own self, right? Because a lot of these are Air Force pilots, and they're going, what is that thing? You can watch videos on YouTube. I'll let you go and search that up. But those just be super classified? One particular program of the Air Force that has been around since 1950 when this research was being released. Bear in mind that T.T. Brown was doing this research in the same period of the 1920s. And he was putting out the work between the 30s and the 50s. And then, of course, he was suppressed just like a lot of other people. Harlan Arp and Velikovsky both suppressed in the 50s and 60s. So where are we at now? There's a whole lot of science fiction that is masquerading as science, and it's easy for that to happen, and I'll tell you why. When you have a whole group of people raised on science fiction fantasy, and they can't tell the difference between the reality and the fiction, they're going to naturally go to school, and when they're done after 4 years, they're going to think they know something, just like I did. And they're going to try and go out and prove that stuff right. And they're going to make up things like gravitational redshift. Why? Because they don't want to look up what intrinsic redshift is. They don't want to look up what a z-pitch is. Black holes are a concept that it mathematically has existed for almost 100 years. But the actual concept of a black hole is a collapsed gravitational star, which you can't collapse a gas in space, okay? You just can't. If you take a gas and you put it in this room, it's going to spread out. You can't hold it it won't gravitationally suck into anything. Right? And accretion's already been debunked, so I don't need to waste my time in accretion. But what I'm saying is that you have these guys, they basically come up as students of this. They're enamored of their professor, naturally. They want to please their professor, so they also start talking about black holes. And pretty soon you got movies about black holes, because they're fascinating. There's that fascinating idea. A window into, what was that movie that just came out? It was not that many years ago. I keep wanting to say Inception. It's the one. And he goes into a black hole, and suddenly he's in his house, and it's alternate timeline. It's fascinating stuff. It is, however, still fiction and fantasy. And I'm not against fantasy. I love watching fantasies. I love watching science fiction. I think it's good stuff. Many times science fiction becomes science fact later on. But there's a big difference between science fiction that is challenging to the current paradigm, like some kind of 2001: A Space Odyssey, and science fiction which is just Harry Potter shooting sparks out of a wand. I mean, that's not how wands work in the first place. Is there an effect in which wands work? Yes, there is. I will tell you. I'm not going to tell you how. I'm not going to talk about that because that is a secret science that, frankly, I don't know you. I don't know whether or not you could be trusted with it. But there is an effect, and it is all related to the quantum realm. But that doesn't mean that you're ever going to hold a wand and it's going to go be like, and spit out some magic sparks. You're going to have a Kamehameha wave with the opponent. You can actually find YouTube channels purporting to be science channels, and all they do is take things like Dragon Ball and Marvel and Superman, etc., and turn it into a form of science. But it's not science. That is not science in the least, no more than just religiously being angry about anybody that has a different opinion, and just only promoting one view of cosmology is science. That's not science either. It's not scientific to say that, well, Darwin's right and therefore there's nothing else to discuss. And if you go to biology, they've gone further than Darwin. Darwin is only 40% of the show at this point. But you will still find people who are raised on that, who will argue with you tooth and nail that Darwin was all correct and that to say anything else is blasphemy. Why? Because they are scientific conservatives and they are not themselves aware of the fact that things have gone on. Do yourself a favor and search Harvard Gaia Hypothesis PDF. Now, do people agree with the Gaia hypothesis is? No, they do not. I mean, you've got people who are going to take it to a new age level, and you've got people who are going to talk about fractals and self-emergent properties, and you've got people who are going to say that it's actually just some function of evolution. I agree. It is absolutely part of the law of flux, part of the law of evolution, the law of change, whatever you're going to call the E, which corresponds to the wind trigram. It is a huge study all on its own. Quantum's down here at Earth, and the evolutionary study is up there at wind trigram, and it's an important part. But it is, after all, still all part of the electromagnetic phenomena. In fact, I would hazard a prophecy here that unless we find electric arc discharge at the South Pole and Mars, you're not going to find life in that water, because you need electromagnetic behaviors to create the organic compounds. That's how they're emergent property from the electromagnetic field. It is not a separate thing. It's not like the Mandelbrot and the golden ratio are over here and electromagnetism's over here. The electromagnetic field is the ether field. It is everything. The way that plasmas behave, the way that solids behave, liquids, gases, all of fluid dynamics, all of the magnetohydrodynamics are actually all functions of these particles and light interacting with each other. I mean all light, right? The entire spectrum, which is to say plasma electromagnetism. Now let's talk about the man's future. What do I see? Because this Age of Unlightenment appears to only be continuously going on, I think that there is some argument to say that there has to be a turnover. Now, I don't know when that turnover is going to be. I'm not purporting to be in contact. I work for my Lord, but I don't receive some kind of fax. I don't connect with aliens. I don't have any kind of special knowledge about what's going to happen. I see a dark cloud approaching, and I just call it Nemesis because that's what they called it in the ancient days, right? They called the planet Nemesis. But I don't know what it is, and I can say that it may be very difficult for mankind to make it through. I think it's important that we start taking our knowledge that we've gathered and that we start putting it into crystal memory and into stone, just like they did in the old days, and putting it all over the world, actually. We should probably be carving entire mountains. I mean, we clearly can blow up mountains and change them, so we should do this. We should be putting all our encyclopedias, and we should, of course, create a system for how to actually decipher that, because once people forget a language and forget mathematics, how would they know exactly without a Rosetta Stone? So we'd have to create a Rosetta Stone. It's very hard to even just describe what a color is. You see people, they see blue, and some people, this blue looks more green, according to me. So how do you create that kind of memory system? I don't know. We've got to work that out. Crystal memory is a good thing. I don't know how quickly we're going to get it to market, though, because we need to start putting, everybody's computers need to go on crystal memory. Because then if the earthquake happens, if we get the 10.0 and everything collapses and it just makes a layer to cover me up, this computer needs to be able to hold a memory that somebody can dig up and plug in later on, or examine under a microscope and go, hey, there's intelligence in this. It's been put in here. So far, we don't have anything like that, and these memory devices are not sufficient to even last 100 years, let alone 1,000 years. And what we see in these cataclysms, from the research, we see that once these cataclysms happen, you might expect upwards of 3,000 to 6,000 years of a blackout, but lately it's not been as bad. I think it depends on how close the celestial body that approaches is. Now, I don't know. Again, I don't know if Planet 9 is a dark planet like WASP 14b or whatever the name of that one is. It's like a black body planet that's made of liquid hydrogen, liquid metallic hydrogen. I don't know if that's what's Nibiru or Planet 9 or Planet X, whatever you want to call it. And I don't even know that that's the event that could cause it. I do know that we need to start storing our media differently than paper, optical, and magnetic, and semiconductors. Semiconductors, I mean, they lose data all the time. So you really can't rely on quantum tunneling in order to create a permanent device. So I am concerned mostly about man's consciousness. I am concerned about our delving into and kind of like going over the same things, and it's because we're not educating each generation how to educate each generation. You see, we educate a generation, and they grow up assuming it's all about them. From baby boomers to Gen X to millennials, it's only become more about them every time. And of course, it's about none of us. It's not about you. It's not about me. And it's not even about my kids. Although right now it's about my kids because they're growing and they're the seeds. We have to teach each generation how to teach each generation how to bring forward things, or we are going to allow them to manifest the various hells. You know, and in Buddhism, at least, and Hinduism in general, the hells are misery, animalism, greed, lust, which is called the hungry ghosts, and anger, the rakshas, the demonic state. Those things are contained within each individual, and it takes time to bring that out, to transform that and push it out of the person, or to enable their better self, the mind within the mind, to be more in control than the other one. And we don't have any schools that teach it, right? There's not even yoga classes, which is just stretching. Okay, there's no like health classes to talk about your chi and your essence, right? All these kids, they're on their own, and if they are already autistic or they're already handicapped, or maybe they're just jerks because their parents are jerks and they've learned to be jerks, it'll be lucky if they come out of it. I was lucky to come out of it. Okay, I was incredibly jaded by the entire process. It's a miracle, and I guess it's just where I keep digging, and I never stop mining for the future. But I was a complete asshole, and I was an atheist, and I was just completely disconnected from everything, right? That is not going to serve us in the future. Now, we got to deal with the fact that there are also ideologies out there, from socialism to jihadism, to all these kinds of ideas. You got Westboro Baptist Church. I mean, these people are loony. And I don't mean loony because like I sound loony, but there's a science behind what I'm saying, and you could go look it up. You can read the papers. You can get the citations. I got like 500 citations in my papers, you know. You can go and look all these things up. These people are loony because they're not coherent. They're not with us. And I don't care if they're spewing about Ptolemy's flat Earth or whatever it is. They just aren't with it. They can't connect in life. They aren't part of a greater field of consciousness, and that greater field of consciousness is the one we want to win. If we want it to win, though, you have to be the change you want to see in the world, and I am not seeing people being honest with what's necessary. You have to be ready to fight. You have to be ready to actually defend yourself against the incursions of the forces of the darkness, of going backwards, of eliminating women's rights and all these things. You know, there's such a huge push to go backwards right now. The Age of Unlightenment is just really pushing hard to sever everything from man, woman, parent, child, all traditional like systems of knowledge, everything, and then replace it with pseudo knowledge. And that pseudo knowledge, where everybody, you just make up whatever you want. And when you make it up, it's all perfectly good for us to, well, why not? We'll just teach flat Earth in school. Why not? Why not? Shouldn't it be taught? I mean, it was part of human history. Yes, well, we should teach about it, but in context of why it's wrong. All right, what's incorrect about it? Because these kids are vulnerable. They're getting on YouTube and they're being inculcated because they don't trust their teachers. They don't trust the schools, and I wouldn't either. Right? I personally think we should probably go back to the governess system of schooling, because kids back 100 years ago were incredibly more intelligent. Go and look it up. You can see papers of the kind of tests they had to take in the 5th grade, and you'll be hard pressed yourself to know if you ever knew that information. So we've talked about that. Okay, so one thing that we need is to solve our energy issue. Now, I want to say right now, if there are any energy executives listening at all, or if you know any energy executives, you tell them, I can teach you to green up and make more money than oil and coal and anything else, even than nuclear, even than thorium. I can teach you how to charge a cheaper bill that makes you a higher profit percentage on green technologies than you will make on oil and natural gas, etc. And of course, it'd be better for the environment, better for humans. It's really more about better for humans, because after all, the environment's going to do great with more carbon. Trees and bushes are going crazy. They're super happy. Algae's blooming like crazy. Now, that's not good for us, right? Because the algae kills off the fish, or it kills off the coral, which kills off the fish. And that's just going to be hard on us. And it's not like fish are going to die off, right? Even if they get to a very small few species that remain, because there's some species of fish out there you can't get rid of. They'll come back. Right? Amphibians will come back. Everything can come back. You can gamma irradiate a section of desert for 10 years straight. All mammals will go away. The reptiles will still be there. Okay? So they're not going anywhere. The insects, they're not going anywhere. The planet will be fine. The question is whether or not we will be fine. So I'm going to list now a series of things that I believe that we will be able to honestly harness in order to make electricity in the future. So let's talk about. Well, let's start with the originals, which are things like. I'm still opening that paper to try and find my full list. So you've got geothermal. Well, what's the extreme of geothermal? Because it's one thing to have a geothermal, furnace that goes down into the ground and harnesses the hot air. Why aren't we harvesting the volcano? There are volcanoes around the world, and there are rifts that are constantly putting out gases that can be used, magma that can be used. Why? We have a tough time with the temperature. Okay, well, don't we have robots? Aren't we building AI? Can't we do deep mining in order to get more of the high temperature materials that we need? And we've got to stop plowing the surfaces and chemicalifying the arable land that we need to actually grow food, and go ahead and get down deep. I'm talking, 300 or more feet into the Earth's crust and get those minerals that we need. All right, well, there are things out there. We can go 10,000, 13,000, 30,000 feet in some places down in the crust, and there's plenty of gold. There's plenty of even, it might not be so easy to get helium, but there are some things that there will be plenty of for human need. At least time for us to go capture some of those asteroids from a destroyed planet. What's another one? And of course, we've got wind turbines. Well, there are actually wind turbines that have been around for 1,000 years in Iran that are vertical. We've got to start making these vertical turbines, because why? Unlike the ones that are rotational and they spin around this way, they take up a lot of space. You can't have anything near them. Planes could be chopped up, birds could be chopped up, everything like that. Well, these ones are cylindrical. They are modular. You can stack them this way, you can stack them this way, you can stack them this way. So the same bit of wind, it's getting slowed down, but it's still turning them as the wind passes through. And you can make huge fields of these things, huge fields of them. You can also capture wind energy just through vibration. So if you have a massive series of awnings over top of a parking lot, so you can put solar panels on those awnings, and then when the wind goes across the awnings, because of the Bernoulli effect, it's going to lift and vibrate those roofs. You can also put generators in each of the support pillars for those roofs. You can cause them to vibrate and generate electricity. And on top of that, you can cool them with water, and through thermal exchange, you got hot water for an entire area. We can also capture wind energy from passing cars as they go by. Little paddles can capture wind energy and just kind of vibrate like this. So many. I don't even think I could finish them all. You got wind kites. You've got wind. We should be capturing wind up on mountains. Of course, the wind up there is much better than wind in the plains. Although the wind in the plains is pretty good too. It's just that there are places where the high winds are constant, and they are an extreme nature. What else will we have? You got river turbines. Well, how about current turbines? How about waterfall? These are actually happening. You can go watch those waterfall generators where they siphon off some of the water. I mean, we're already expecting a drop, so there's potential energy due to the relative height, and then you just drop it through a turbine, and when it drops through, it's perfectly fine. Of course, and you can easily steer fish away. That's not even a problem. You just put up a mesh, like chicken wire, basically, and it just guides the fish away from it. They stay away from the waterfalls generally anyways because they can hear it, and boom, you've got more generation going on there. What else do we have? Right, so what I want to talk about is let's see, I've covered this: tidal, river current turbine, standard geothermal. Good. Okay, now let's talk about stellar signal collection. You may not realize it how photovoltaics work, but they're essentially diodes that have a special curve that so happens for a brief moment there is a negative voltage output and negative current output in the if just the right levels of heat strike that diode, and it will put that out. Okay, well, that is only a select band of the spectrum. What if instead we were building quarter wave antennas? Lots of them, of course. We'd have to make them just like we make these microchips, trillions of times, and really incredibly small, but lots of little quarter wavelength panels of antennas that would be collecting radio waves and X-rays, and really all sorts of frequencies. We could probably make a mesh, sort of like a plywood sort of design, where it's collecting all sorts of frequencies that we know are coming out of the sun. We have the spectroscopy for it, right? That's capturing green light, for example, or even just the blue light that's refracting around us here because of the oxygen. And then convert that, because that is already an electromagnetic signal, right? Whereas with the photovoltaics, you need it to be a certain range for that to work. With an antenna, you would be collecting the voltage itself. I don't know why this hasn't been done, except for, the voltages are obviously incredibly small per quanta. But when you add them up, you're going to gather a lot. Now, you would need factories that could produce semiconductor wafers. They need to be focused on that. Right now, they're focused on what? Making chips, making phones, and making, stuff to sell people to have a good time. The good time's going to end, though, and when that good time ends, we're going to wish that we had, easy energy generation. Remember that, we can burn energy for a long time, but then eventually there's only so much to burn, and then eventually it takes time to grow the planet back. What else do we have here? So we have also planetoids. They have charge. They can be captured for minerals and for charge. You've got a entire solar, just above the Earth, you've got a solar wind that is pumping massive, untold amounts of power. Just in the atmosphere of this planet is 350,000 amps, at least, that we know of, circulating at all times. We should be harvesting this stuff. We are not currently, because we don't know how to shield such devices, and we don't have our moon base. We need a moon base to get this stuff going. From there, we can launch, of course, a Mars base and asteroid bases, creating relays where we can collect charge with giant gold foil, and we can beam it as X-rays or gamma rays to a specific dish that then receives the voltage and current of that stream and converts it into the current that we use, which is only 60 hertz. It's nothing compared to the power of an X-ray. What's coming through your wall socket? If you've ever touched it and it's very unpleasant, that's just 60 hertz, and that's just 110 volts, and it's not even hardly enough current to. I mean, sometimes it could kill, but not usually at the wall. It's not going to kill you. So that is it's not hardly anything. We would have more than enough. I mean, just that alone, we wouldn't need all the wind. And of course, we should still make solar. Do you know that we can make solar? We can make in the deserts giant solar steam plants, and these steam plants themselves would then provide not only hot water but cleaned water, because then the water would have been superheated by the sun and by UV, because you can cleanse water by putting it into one of these bottles and just sticking it in the sun. UV will cleanse it, and we can pump that water, then water that's actually under the Sahara, for example, and put it around. And actually, there has been patents of devices that pull water straight out of the air with nothing but salt. And of course, the military snatched those up too. But we can all just, and once it gets out there, everyone could build it, and nobody could stop you. That's the direction we've got to go. We've got to use this internet to put it out there and let nobody. We got to replicate it everywhere. Just like a virus, that information needs to go everywhere. And of course, you've got things like lightning collection, hurricane vortex, supercell harvesting, landfalls, just the slippage, just waiting for the slippage, with a super mega capacitor lying in wait in places where there's a constant general slippage or a constant subduction, Indonesia, California, these places where, boom, it hits and we can collect that kinetic energy and quickly generate massive amounts of electricity. The whole city of LA is all the electricity it'll need for years, boom. To me, it seems common sense. And what are you going to do? You're going to provide jobs, more than enough jobs for everybody. You're going to provide energy for more grow lamps to make more plants. Because we can be growing inside of old mines. We can be growing inside of caves. We can be growing inside of old warehouses. Everything that is currently an empty space can be converted. If it's an empty field, it can be converted into a forest farm. If it's an empty warehouse, it can be converted into something else. Now, do we want more humans? Maybe not. Maybe we should stop at about 11 billion as projected. But still, we're going to need that energy. We're going to need it to get places. We're going to need it to ride the solar wind if we're going to do real star travel at all. Because we're not going to do it going slower than the speed of light. And we're certainly not going to do it in explosive rockets. There's plenty of science fiction videos about what happens when people have to live with each other for too long. Everybody goes crazy. So we really can't do it that way. We got piezoelectric, right? The whole planet's made of quartz, the whole crust. Every time there's a flexing of the crust, or there's a change in the PIMS and the hejim, the quartz generates electricity. There's going to be a way to capture that. And of course, earth resonant power plants using plasma, just like the Giza power plant. Then aside from lightning collection, there's also the possibility of sprite collection. There might be a whole business of viability of people who fly airplanes. They're not really airplanes. I mean, they're airplanes, but what they are giant, solar panel planes that never come to the ground, and all they do is collect sprite electricity, because the electricity in the troposphere must be insane compared to just what's in clouds. And just collect that, and then they just beam it to a satellite, which bounces it to the same solar collecting station. This is the kind of thing that we can do, and we should do, in order to help the future of humanity. But we're not going to be able to do it so long as people keep saying things like, you can't make enough electricity with solar. You can't make... No. Stop lying. That is not true. Don't tell people that there's not enough room on this planet for people. You can fit everyone on this planet onto Australia. And if you could just terraform Australia into a complete paradise for farming, if it all was like Kentucky all the time, there'd be more than enough room for everybody. Now, that's not the way we want to live. That's not what we want to do. But slashing and burning forests to make farms is nonsense. We should be slashing and burning to create paradises like they did here in Kentucky. That's what the natives did here. That's why Daniel Boone was so impressed. The trees were so large, the ground was so open, and there was so much game. It was because they were burning, and they were doing controlled burns of the forest here in this state. It's all a matter of consciousness. It's a matter of think and you will become. What you focus on expands. And we have to do more of that, or we are going to suffer the consequences. That's my final message for how we can get out of this age of enlightenment. If you like this video, please consider like, share, subscribe. And I hope that you have a good rest of your weekend, and I will see you in the week.